Okay. Okay, you should be able to see my screen, and here we go. Just keep in mind that when it comes to the partial fraction decomposition as a statement, the entire chapter section is relating to partial fraction decomposition. And I'm going to summarize this with PFD, because I'm not going to rewrite it 50 times. This one, what's unique about it is it has distinct linear factors. That's what makes it unique. Distinct linear factors. So an example of this. So the question stem in this case will say find the partial fraction decomposition of. And so they're going to give you the question, which in our case here in purple, x plus 14 divided by x minus 4 times x plus 2. So let me just stop for a minute and explain something to you. And so when they refer to this as having distinct linear factors right here, they are referring to these guys down here. They are quite simply two binomial factors that multiplied with each other could give you potentially a trinomial. And so obviously in some questions, they're going to give you a trinomial and you'll have to factor it to this state right here, or they'll give it to you just like this and you'll figure it out from there. Now, here's the trick. Let me do this in green so you follow the logic. Because there are two distinct linear factors, we're going to use a over x minus 4 plus b over x plus 2. So those are your two distinct linear factors. The a and the b, the a becomes the numerator for this and the b becomes the numerator for that. Okay. What happens here is that we are now going to look at all of this as a question. Okay, and remember that now we're setting this equal to that. So if I'm solving in this case, the first thing I'm going to do, since my denominator is x minus 4 and x plus 2, I'm going to literally multiply on both sides by x minus 4 times x plus 2, and do not skip steps because you will see why I say that. Notice that I'm multiplying by that same value on either side. If you're with me, what you should notice is that on this side, on the left side of the equation, we'll call this the left, and obviously this is the right. So on the left side of the equation, both of these are going to cancel out, leaving you just the original numerator. And this is going to be set equal to, and now I want you to understand, I'm multiplying all of this times this, and then all of this again times all of this. Now, what happens is the numerators are going to end up swapping denominators. So you'll end up with a parentheses times, and then you'll end up with, in this case, the x plus 2, because the x minus 4s initially are going to cancel. So in other words, if I'm multiplying this by x minus 4 times x plus 2, the x minus 4s will cancel, leaving you a and x plus 2. Plus, and now in this case, since I already have it right there, you'll see the x plus 2s will cancel, and you're left with b times x minus 4. And now we just solve this as a basic equation. So you'll end up with x plus 14 is equal to ax plus 2a plus bx minus, I guess, 4b. All right, so far so good. And so what you want to do then is take the terms within x, and you're going to group those two together. And so this becomes x plus 14 is equal to ax plus bx plus the 2a minus the 4b. All right. If you notice, I can extract the x out, and this is going to leave me a plus b by itself. So I have x plus 14 is equal to the a plus b times the x. And then in this case, I'm left with plus the 2a minus the 4b. This is where this part of the equation comes in. There is technically a 1 here. This 1 is a plus b, because this is a plus bx, this is 1x. So this piece is equal to this piece. And then the other part that we do know is that the 2a minus the 4b, which is the loose piece, is 14. So what we have is we have a plus b is equal to 1. Hence, a plus b is equal to the 1. And we're left with the 2a minus 4b is 14. So 2a minus 4b equals 14. And now we have to solve this using a system of equations, because that's in essence what you have here. So if I know that a plus b equals 1, then what I'm going to do in this case is I'm going to say a is equal to 1 minus b as an example. And so what I'll do is I'll solve for b by substituting this in here. So I'll have 2 times 1 minus b is plus b is equal to 1. I'm sorry, plus 4b is equal to 14. I end up with 2 minus 2b.
Would it be minus 4b?
What happened?
Would it be minus 4b?
It is minus 4b, yes. I did not change it. So when you multiply or distribute this 2, you get 2 minus 2b minus 4b, because that doesn't change. There's nothing happening to that, is 14. So that means that 2 minus 6b is 14. When I subtract this 2 on both sides, that'll cancel. That'll leave me negative 6b is equal to 12. Oh my gosh, 1 R apparently. And therefore, when I divide by negative 6 on both sides, then I find out that b is equal to negative 2. Well, bring this back to that equation, we could solve for a easily. That means that a plus the negative 2 is equal to 1. In that case, if I add this 2 to both sides, A is equal to 3. And if you go back and you substitute it, obviously 3 minus 2 equals 1. If I check it out, then 2 times 3 minus 4 times negative 2 should equal 14. Let's see if that is true. In this case, you get 6 plus 8 is 14. So we checked it out. It checks out. Now we're not done. That's not the answer. We now have to go back and plug this back into our equation where we originally had the A over here, where we had A over x minus 4 plus B over x plus 2. And so this final answer ends up being 3 over x minus 4. You could write it as minus 2 over x plus 2 if you wish. If you'd rather do 3 over x minus 4 plus negative 2 over x plus 2, that's okay as well. This is a more complete answer though. How do you feel about this, and would you like to try another one on your own?
I would like to try another one.
You want to try another one? Okay, so here we go. So let's do a try. Try to answer this one. And use the one I just did with you as an example. I'll give you 5 minutes. And then we'll do it together. All right, go ahead. I'm going to start my timer. If you finish earlier, let me know. Okay, I assume you should be done by now. If you're not, remember this is being recorded. We can always go back. I am going to go over it with you. So two distinct linear factors, we'll call them A and B, as you can see here. And so this is how we begin to set it up. We know that we're going to multiply by a common denominator on both sides. And so we'll repeat that process on the left and on the right side. And what'll end up happening is this is going to cancel with this. And these guys are going to end up swapping. So you end up on this side with 5x minus 1 equal to a parentheses x plus 4 plus b parentheses x minus 3. So they end up swapping because, like I said, you know, this cancels with this on this side. And on this side, you'll have the x minus 3 cancel with the fraction as well. So these guys cancel, and that's how you end up with a times x minus 4. All right, and so once we distribute, now this becomes just basic algebra. 5x minus 1 equals the ax plus 4a plus bx minus 3b. We're going to group the x terms, so you get a plus bx and then plus the 4a minus the 3b. Now there's a reason I put them in parentheses, and that's to keep you organized. So here's what we do know. Follow the color code if it helps you. That means that what's in front of this x, which is a plus b, has to equal that 5. This -1 is the actual value of 4a minus 3b. That's what you know so far. So if a plus b is equal to 5, and you know now that 4a minus 3b has to equal -1. Solve for this in terms of one over the other. So I'll solve for a in terms of b. So this will be 5 minus b. I'll subtract the b on both sides. And then I'm going to take this 5 minus b and I'm going to substitute it in there. So now I have 4 times 5 minus b minus 3b is equal to -1. This gives me 20 minus 4b minus 3b is equal to -1. And so 20 minus 7b is equal to -1. If I subtract the 20 on both sides, that'll cancel. That'll leave me -7b is equal to -21, and therefore b has to be equal to 3. If b is 3, then a has to be 2. Because a plus 3 will give me the 5, and now I just solve for a, which gives me a is 2. My answer should be 2 over x minus 3 plus the 3 over x plus 4. So how many of you got it correct? Hello?
I did. I got like 5x x plus 4 minus x minus 3, and so I got 8 divided by x minus 3 minus 3.
So you made
divided by
a
x plus 4.
mistake, a math mistake?
Yeah, I did the same thing, but I realized what I did.
These types of questions, based on what other students have told me, start to click very quickly if you repeat them. Like do this again and then try a different one after the fact. So maybe do the first 2 we did together. You'll have the video to double check it. Repeat it just so you get the cycle of what's happening, and then you'll move forward with that. I promise you. Okay, so that's the first type of partial fraction decomposition. Example 2 is kind of similar, except there's a difference here. The difference in example 2 is that yes, we have partial fraction decomposition, but this time with repeated with repeated, keyword, linear factors. What that means is that I have a square, a cube, that kind of thing. They're still distinct. They're still distinct, but they're repeated. So for example, here's your question. It'll ask you to find the partial fraction decomposition of, and then they give you x minus 18 as an example over x times x minus 3 squared. When they say repeated, they mean this. So if I expand that for you, you would say, oh, so this is basically x times x minus 3 times x minus 3. Hence, concept repeated. Repeat. It's the same function, just same factor happens more than once, that's all. When you do have that, you have to break this up into 3 fractions. In this one, so you're going to have the x minus 18 over the x times x minus 3 squared. Now, immediately you must be thinking, well, just group the x and group the x minus 3 squared alone. No, you have to remember that this is its own factor as well. So there's actually 3 separations of the denominator. So you're going to start with a over x plus b over the single x minus 3, another color, plus c over x minus 3 squared. Do you see where I'm going with this one? Do you see what I mean by you got to take out that single that is repeated? That's the difference between the one you did in example 1 and the one you're doing now. Okay, if you're ready to roll, here come the next steps. Are you with me so far, or do you need a minute to take this in? Keep going? Yes, keep going or no?
Yes.
Keep going? Okay. So now what we're going to do is we're going to multiply by the LCM, which is basically the x times x minus 3 squared. I'm going to do the same thing over here, which is x times x minus 3 squared. Obviously, on this side, we cancel nice and easy. We're left with x minus 18 equal to. On this side, we're left with a times x minus 3 squared. Follow the color code if it helps. On this side, you're left with b times x minus 3 squared. And the last term is your c term plus cx.
I don't get the part that
This should be just a 1. Huh?
I don't really get the part that's in green. Why would we do?
No, it's not squared. It's just x minus 3. Because remember, this is really x, this piece.
Divided into 2 parts.
Yeah, it's really x times x minus 3, and in theory, x minus 3 again. So if I'm dividing that into this, well, let's start with the a. The a term, this just goes away, leaving you just the x minus 3 squared. For the b term, we're only taking away one of these, so you should just have x times x minus 3. For the c term, you're really only missing the x.
Makes sense. Okay.
Yeah, sorry, I wrote the square and then I was like, what am I doing? All right, so guess what? FOIL distribute, leave alone, and now we solve. So you have x minus 18 is equal to a times x squared minus 6x plus 9, right? That's a special product FOIL. Plus b times x minus 3. So actually I could write that out completely, but I'm going to leave it like that for now. And then plus the cx. This eventually will spread out. This will become b times xx, which is x squared, minus 3b, and then plus cx. Sorry, I forgot the x. Because remember, you're distributing this here and here. And then on this side, this just stays as ax squared minus 6ax plus 9a. So basically you're just spreading out all the, or distributing all of the variables. Okay, ready for the next part. So if you'll notice, you have x squares. You've got some basic just a's, so ax, anything with a 3 on it or x on it. So the ax squared, bx squared, 6ax, 3bx, that's this one here. And then you're left with your 9a and your cx. So you're going to group those together. So these guys, this one and this one, are now a plus b and then this is the x squared part of the formula. You have an x part of the formula, which I'm going to do as plus negative 6a minus 3b, and then plus c, I forgot the c, my bad, plus c, and then the x comes out here. And then you're left with just the plus 9a out on the outside. So this part is part of the x pack. So if you'll notice in green, negative 6a minus 3b and the c, the x stays out. On this side, the a plus b, that's this a and ax squared, bx squared, that's these guys here. And what's left alone is just the 9a. 9a is your only one. Now remember, this stays out here. Now go back to this, you have to fill in the missing x squared. So this is 0x squared plus 1x minus 18 is equal to all of this. So we now have a system of equations. Follow the a plus b. So a plus b has to equal 0. Follow this part here. That has to equal 1. That's your minus 6a minus 3b plus c equal to 1. We're going to finish that off with, in this case, 9a has to equal the negative 18. That's this part here. So follow the yellow code and you'll get where I'm going with this, where I went with this, I should say. I'm not going to highlight, well, we'll leave it at that. Okay, so with,
for this, can you just figure out A, then figure out B, then figure out C in that
yeah,
order?
that's exactly what you're going to do. Because in this case, we know that A is equal to, this has to be negative 2. You know that because here, 9 times -2 has to be what gives you -18. So we're good there. So if I know that A is -2, then -2 plus B is equal to 0. So B has to equal +2. And now to solve for C, very simple. Go back here using that information. -6 times -2 minus 3 times 2 plus C equals 1. So you end up with +12 minus 6 plus C equals 1. So if 6 plus C equals 1, therefore C has to equal -5. And there you go. C is equal to -5. We're not done. The final answer resides here. Remember, it's -2 over x plus +2 over x minus 3. In this case, you could do plus and then do the negative up top at the numerator, or you could just do minus the 5 over the x minus 3 squared. And there's your A, your B, and your C terms in terms of partial fraction decomposition. How fun is that?
It's a lot of work.
It is a lot of work, but it's easy, right? Generally speaking. I'll bring it down so you can copy whatever you're missing there. I would like for you to try one. I'll give you 5 minutes. I think that should be enough. If it isn't, you can always replay the video. So same question stem, find the partial fraction decomposition for x plus 2 over x times x minus 1 squared. I'm starting the timer now. Okay. So if you want to check your work, I'm going to give you the answer. So for this one, you should have 2 over x minus 2 over x minus 1 plus 3 over x minus 1 squared. Talk to me.
I wasn't finished yet.
Oh, are you on your way?
But like, yeah, I'm on my way.
As long as you're on your way and you're getting the right answer, so we're good so far. I assume that's the same for the rest of you? So check your answer and let me know what questions you have.
I got 2 over x minus 2 over x times x minus 1 minus 1 over x minus 1 squared. I got a -1 for C.
Me too.
All right, let's see what happened. All right, so we start with the first step, which after you set it up is basically going to be to multiply by the denominator x times x minus 1 squared on both sides. So x times x minus 1 squared, where this cancels with this, leaving you just x plus 2 is equal to, and then when we multiply this, you realize that you end up with a times the x minus 1 squared plus bx times x minus 1, and then lastly plus cx. When you do that, you have to remember, because you have a square, you're going to end up with 0x squared plus x plus 2 is equal to a times x squared minus 2x plus 1 plus bx squared minus bx plus cx. So if I distribute the a, I'll have everything I need. This is 0x squared plus technically 1x plus 2 equal to ax squared minus 2ax, and then plus a plus bx squared minus bx plus cx. All right, and so we want to gather anything that is an x squared together. So x squares. So that means that we have an a plus b in parentheses with the x squared that matches here. We have the minus 2ax minus bx and cx. So if we take the x and we extract it, we're left with, in this case, minus 2a plus, minus b plus c. And all of that is with an x. And lastly, you're left with the a term by itself. A term is sitting here by itself, so you have a plus a sitting there. All right, so given this information, we know that a plus b is equal to 0. All right, and you know that because that's your x squared term. We also, based on this, know that negative 2a minus b plus c has to equal 1, and you know that because that's your x term. But we have a gift that's given to us right here, and we know that a is equal to 2, which means that b has to be negative 2. That's everything you need, really, because now you just substitute it back in. Negative 2 times 2 minus the negative 2 plus c is equal to 1. So this is minus 4 plus 2 plus c is equal to 1. If I combine these two, I have negative 2 plus c is equal to 1, and therefore c has to be equal to positive 3. So there's my a, my b, my c. And so if I know that, then I know that my answer is 2 over x minus 2 over x minus 1, and then plus the 3 over x minus 1 squared. And that goes back to your original setup. Okay, so for today, I'm going to stop here. I think I've given you guys enough of a welcome from spring break. So much for chilling.